My name is Stephan Mühlstrasser from PDFlip GmbH in Munich, Germany, and my job is software developer at PDFlip, and I also was the lead developer for the PDFVT development, so that's the reason why I'm here. So the agenda and a few words. Duff and I talked before about the contents of our presentations, and we were both aware that we would have some overlap. And when I learned that I will come out second with my presentation, I thought about what I would keep in the presentation and what I would take out, because it would be probably redundant to Duff's presentation. And in the end, I decided to leave it all in. So I have a lot of slides that also talk about the ISO 16612-2, because I wanted the presentation to be self-contained. So if someone takes the presentation alone, it makes sense. So the PDFlip stuff is in context. But because I have only about 25 minutes left, I will skip very quickly.
You can take a few more minutes.
Okay.
That's okay.
I will skip very quickly over most of the slides because Duff already covered this in enough detail. So I have a short introduction about PDFlip and about the PDFVT standard in general. Then I will have a longer talk about the PDFVT standard and how we implemented it in PDFlip. Then we have a section on the lessons learned during this implementation, and I'll conclude with a short outlook and some references. So first, a few words about PDFlip. PDFlip is already a while in the business of developing software for creating and processing PDF documents since 1997. And all of our products are developer products. So they are mostly libraries, but also some come as command line tools. And what I'll talk about today is the PDFlip family, which was the first product, obviously, of the PDFlip company. And it comes in different variants. We have PDFlip, plain PDFlip to create PDF documents from scratch. We have PDFlip plus PDI, which adds the capability to import PDF pages from other documents. And we have PDFlip personalization server, or abbreviated PPS, for high volume personalized PDF creation. And since mid-2011 we have PDFlip 8VT, which is an extension to all the three editions above, with the capability to create PDFVT. All the products are supported on a wide range of platforms, so you can have PDFlip for mobile systems, you can have them for desktop or server systems. Even on mainframes we sell it, and we also support a lot of programming languages, so we're not restricted to one specific language. And how are the products used? They are typically integrated by OEMs into their products, or for example used by web developers for the online invoices, for example. Okay, Duff talked about in detail about the PDFVT standard and about the conformance levels, and I just wanted to show you an example document. Obviously, I'm still living in the world where invoices are printed, and this could be an invoice, and what I want to focus on these slides is the recurring graphical contents. So we have different kinds of graphical objects here. So if you look at the barcode, which encodes the address data probably, it will appear exactly once in a huge PDFVT file with many, many invoices. We have the company logo that is potentially used globally, so maybe even in all files that are printed by this specific in this specific environment. And we could have an image. We imagine that you could put an image of a sales rep into each invoice, so each customer would know who his sales rep is, and this same image, the same image X object would be referenced in multiple pages in the PDF-VT file. So why would you want to use a library to generate PDF-VT documents? I think it's pretty obvious. Your data will come somewhere from a database. You will add images, text, or pages from existing PDFs, and you need to have an automated capability to assemble PDF-VT files from this data. And you will create the documents somehow by making API calls into a library, in our case into PDFlib. Okay, I can skip that. Duff talked in detail about what is important, or what the DNA of PDF-VT is. Where did we start? At the time when we started the implementation, PDFlib 8 was released, which supported already all the relevant PDFX standards, and it also supported PDF A1. Currently, we are working on the PDF A2 and 3 standards, which will be available with the next PDFlib version. And how does the basic PDFlib programming model look like? I wrote it down in pseudocode. I didn't want to bother you with an actual program. Just the basic structure of a PDFlib application program is described here. And you start with an API call that you begin a document. For example, in this step, you provide the name of the output file. Then you say with an API call, I want to begin a page. And then in that context, you can create page content with text, graphics, raster images, whatever. And when you're finished with the page, you say with an API call that you end the page, and you repeat from step 2 if you want to add more pages to the document. And you finish the document with an API call that says, okay, the document is complete. And I'll show you in the end, after I explained what we needed to add to this programming model, how a programming model then looks for creating PDF-VT files. So we will have some additional things that the programmer needs to do if he wants to create PDF-VT. So how did we design this effort to implement PDF-VT in PDFlib? Of course, we used the already existing PDFX support. We needed to add a new API for the creation of the document part metadata, and for another API for the creation of the document part hierarchy. I'll spare you the details. I'll mention them when we come to the relevant slides. An important building block was the detection of transparency, because they are very important for the creation of encapsulated X objects, and I'll talk about that later. So now I have the next chapter, which will show slides about what's in the PDF-VT standard and how we implemented that in PDFlib then. Duff talked in detail about the correspondence of the two PDF-VT levels and the PDFX standards. So PDF-VT1 requires PDFX4, and PDF-VT2 mandates one of the PDFX standards that allow for external content, for external ICC profiles and external graphical content. And we had that already. What must the user do if he wants to create a PDF-VT document? He must specify the PDF-VT conformance level that he wants to create. And for PDF-VT1, it's clear that it's PDFX4. For PDF-VT2, the library user must explicitly specify what PDFX conformance level should be created. So next part, I think this is an important part of the DNA of PDF-VT that wasn't mentioned in detail in Duff's presentation, so I'll talk about this a little bit more. Here you see how the document part hierarchy tree is integrated into the PDF data structures. So what you see on the right-hand side is the page tree in the PDF document. And this is just present in every PDF file. So that's nothing new or nothing special. What is added for a PDF file is the document part hierarchy tree. And as Duff said, it could just be one document part. This would be compliant PDF, but you can add as many levels as you want to this document part hierarchy tree. And the PDF document catalog references that document part hierarchy tree, and it contains information about what kind of levels you have in that tree. So these names here, root, recipient, and invoice, were chosen by me, and you can choose any names you want. What you also can have here is optionally the specification of a record level. So you can identify the level in the tree where the individual recipients are tracked in the file. So for the invoice example, the individual invoice recipients. The document part hierarchy was designed to allow efficient access to the ranges of pages in the PDF document. So every leaf node in the document part hierarchy tree has a reference to a range of pages, which can consist of one or more pages. And we also have the back references. Each page in a PDF file must have a reference back to the document part it belongs to. So you can traverse this data structure in both ways.
Can this be multiple references?
No.
One page to diff multiple D parts?
No.
No?
So it's like here, so you would have it also for the other pages and D parts, of course, but it's always 1 to n and n back to 1. So these references must match here.
But the ranges need not be ranges like 7 to 11. Could also
They
be,
must
Must be contiguous.
They must be contiguous and consist of one or more pages. You cannot have empty document parts, obviously.
At the leaf node.
At the leaf node, yeah. So pages are only referenced from the leaf nodes. If I didn't say that clearly enough, thank you. So you have no references up here to pages or so. You always go to the nodes at the bottom of the tree.
These D part definitions, where can they be found? Is it only in the PDF specification, or is it part of the PDF?
It's in the PDF standard.
It's only there.
Yeah.
Actually, it's being added to 32,000-2.
So it's the next version of PDF itself
Yeah.
that also has
It's an
Okay.
extension which is compatible with 32,000-1,
But that's not out
but
yet.
it'll be a formal part of 32,000-2.
Mm.
We work very closely with
Okay.
Okay, this is everything I said. And how did we implement the depart tree in PDFlib? When you start the document, you must specify the list of level names that will appear in the file. And optionally, you can specify the recipient record level, which is just a zero-based number. And the library user then must open and close levels in the document part hierarchy tree while creating the pages. So by that, it's implicitly clear afterwards to which document parts each page belongs. We'll see that in the finished programming model later. Then another picture, how is the document part metadata stored in the PDF file, and it's attached to the depart nodes. And this is the same tree as I had before, I just left out the level names. We learned already that DPM is not restricted in any way. You can put in any data you want, but of course you should do it in a consistent way. So each level should have probably a defined set of fields that make sense at this level. So for example, at the recipient level, we could have name and address. And for example, at the leaf node level, we could have here for a transactional promotional invoice document the statement part and the promotion part, which could be separately identified through the document part metadata. Yeah, here I mentioned JDF, but we will hear a lot more about that later. What then did we need to do to implement the document part metadata? Up to now, we had no low-level API in PDFlib that allowed you to directly create PDF data structures like dictionaries and arrays, because the philosophy of PDFlib is to hide this complexity from the library user. So the library user makes API calls that say, for example, begin page, but behind the scenes, PDFlib does create all the PDF data structures in a consistent way. But obviously now we needed such an API, and for DPM we built one where we shortly afterwards learned, okay, we can use it also in other contexts. So we built a general purpose low-level API for building arbitrary PDF data structures. Yeah, we learned in Duff's presentation that you can put scope hints on the X objects in the file, and the PDF VT reader, the RIP, will use them to optimize the usage of its cache. And how did we go about the implementation in PDFlib? PDFlib is designed in the way that it always, while you make the API calls, it always will write all the data it can write as early as possible. So there are some implications what the user must provide, what information the library user must provide. And obviously it's then not possible to identify, for example, how often an X object is referenced in the file, because when the X object is written out, you don't know that yet. So this means the library user must specify the scope hint, but afterwards PDFlib tracks how often an X object is referenced, and if you violate the scope, it will do two different things. If the scope hint is too small, it will throw an exception. So for example, if you say this X object will be referenced only once with scope single use, and you use it twice or more, or at the point when you use it twice, you will get an exception, because it actually would be a violation of the PDFVT standard to have an X object with scope single use used more than once in a PDFVT file. In the other case, the scope hint could be too large. You could say, for example, scope hint file, but use the X object only once. And this is not really a problem, but it's a missed optimization. So you will only get a warning in the log file, and if you look at the log file, you can get suggestions for optimizations. How can you make your PDFVT file more efficient, potentially? Then one point that was not mentioned by Duff, I think, is the unique identification of X objects. X objects can have a unique identifier assigned, and this is stored in the GTS XID entry in the X object dictionary. And what does this identifier mean? When you have two X objects with identical unique identifiers, they are considered equivalent by the PDFVT reader. And this is, of course, also used by the RIP to optimize the processing of X objects. So if the RIP has an X object rendered and cached, it will remember the unique identifier, and if he encounters another instance of an X object with the same identifier, that's a hint that he can just reuse the object from the cache. So how did we implement this in PDFlib? PDFlib will always calculate unique identifiers for image X objects and for form X objects created from imported PDF pages. We do not have automatic calculation for user-created form X objects, but for that case, the user can specify an identifier himself if he wants to. That's sort of a compromise, and we could add later the capability to calculate the unique identifiers. Yeah, how are these unique identifiers calculated? There's a section in the PDFVT standard that describes an algorithm how to determine whether two X objects are equivalent, and it's a recursive comparison of the X objects. And we calculate the IDs by calculating recursively hashes for all the dictionaries and streams that are referenced from an X object. And we needed to spend quite some effort that we made sure that these unique identifiers are actually the same on all platforms. For example, you cannot naively calculate hashes over integers. If you do not care for the fact, then you can have a big endian and a little endian machine. Or we support PDFlib on ASCII and EBSTIC machines, and that also could make a difference. So we try to guarantee that your unique identifiers are always the same on all platforms. So you could combine files produced by different variants of PDFlib, and they would match together, and hopefully the RIP would process them in an optimal way. Then we heard about encapsulated X object and transparency, and I don't repeat all the requirements. It's important to remember that encapsulated X objects enable the RIP to render the X objects independent of the context of the page. So your current graphic state will not influence how your X object is rendered, and that's obviously a good thing if you want to reuse them. And yeah, this was one of the most difficult parts of the PDFVT standards. First of all, to understand the definition in the standard what an encapsulated X object means and what that means for exposing this feature to the user of the library. And this came out. The library user can indicate upfront when he starts the document whether he intends to use transparency in the document or not. And the simple case is that he explicitly tells, I will not use any transparency in the document, because that allows PDFlib to mark all the X objects in the document as encapsulated. But if the user makes a mistake and actually tries to use transparency, he will get an exception and the document cannot be finished, because that would be a violation then. It could not be any longer a correct PDFVT file. If the user indicates that transparency is intended or it just says nothing, then the default is that transparency is allowed. And PDFlib inspects all the X objects that are written into the PDF file, and only the ones that fulfill the PDFVT requirements will be marked as encapsulated. Yeah, if we import encapsulated X objects from other PDF files, this property is preserved. They will still be written as encapsulated objects into the file. Yeah, because of lack of time, I will skip the environment context because it's not really interesting. MIME support, we heard that you can more or less have an indefinite stream by wrapping the PDFVT chunks into a MIME stream. And that would also allow to start the processing for the RIP without having received the complete PDFVT 2S instance. And how do we support it in PDFlib? We decided that this will be most easily implemented as an application on top of PDFlib. So there are only a few lines of code that are necessary to wrap separate PDFVT2 chunks into a MIME stream. The application must observe some restrictions that the different chunks in the stream must fulfill. So there are some cross-file requirements, and we documented these in the programming manual of PDFlib. And we have a demonstration in our so-called cookbook, which are programming examples for PDFlib. And by doing it this way, we had no requirement that we had to put MIME support into the PDFlib core. It's just added easily on top of PDFlib in an application. Yeah, PDFVT and PDFA, you can combine or you can create PDFVT files that at the same time conform to PDFA. And the motivation is obviously you can archive those files without having to go through another step. And this applies only to PDFVT1 because PDFVT2 has those external references which are totally forbidden in PDFA in all levels. And PDFVT1 can conform to all present and upcoming PDFA standards. What does this mean for the library user? He must respect the set unions of restrictions that are imposed on the file from PDFVT and from PDFA. Otherwise, he will get an exception. So we support this. At the moment, PDFVT1 and PDFA1, the other PDFA levels are coming. The user will get an exception if he violates any of the restriction. And yeah, the current support might not be super attractive at the moment because PDFA1 does not allow transparency, so you cannot use all the features of PDFVT1. So let's put that together. How is the programming model extended? If you want to create a PDFVT file, you begin the document. At that point in time, you specify the desired PDFVT, PDFX, and optionally PDFA conformance level. You optionally specify whether you intend to use transparency. You must provide the list of names of the levels in the document part hierarchy tree, and you optionally can indicate the recipient record level. Then comes the new API for creating document parts. You say begin document parts, which will open a new level in the document part hierarchy tree, and at the same time you can optionally attach document part metadata to the new node that is created by that API call. And if you want to step into deeper levels of the dpart tree, you repeat step 2 before you start a page. So only when you opened enough levels that you are at the leaf node level of the dpart tree, you say now again begin page. You can create page content. You optionally can specify scope hints and environment context for X objects, and for user-defined objects, X objects, you can optionally specify unique identifiers. And then you close a page, you repeat from step 3 for more pages, and with step 7 you will close levels in the document part hierarchy then.
Just a quick question. When you import a PDFX object which has a mismatch in the output intent, how do you react on that?
We document that the user needs to take care that the documents are prepared for the same output intent. So there's no real feature in PDFlib that would compare the ICC profiles for the output intent, which would be pretty difficult if you wouldn't.
So there's a warning, but you ignore basically the output intent. Like
we check. You cannot mismatch, for example, a grayscale output intent with a CMYK output intent. But we will not cross-check different CMYK output intents, for example.
Yeah, like making a PDFVT for newspaper printing, and there's an offset ad coming in, being incorporated, then you will take the data one-to-one. Yes. Even if they might be problematic because they're prepared for something different.
Yes.
Okay.
So we detect some conditions that are easy to detect, but for other conditions the user must take care of it.
Okay.
Yeah, and finally you must close the document part levels. Obviously you must perform step 7 as many times as you perform step 2. So in the end the document part tree is complete, and then you say end document. So what did we learn during the implementation? First, a few words about the standard itself. We were positively surprised that ISO 16612-2 had a higher quality than previous PDF-related standards. So any people who struggled with implementing PDFA and PDFX have to tell some stories about the errors and inconsistencies in those
Olaf,
standards.
auszuweinen.
He knows what I'm talking about.
Warum?
Hij doet ons.
It's a training effect. Once you are at the third or fourth standard, you
Yeah,
actually get
yeah.
better.
obviously. What we struggled with the most was to understand the description of encapsulated X objects and how to translate that into a model that is comprehensible to the user. So it's you can actually program that in an easy way. And of course, the existing PDFX support in PDFlib saved a lot of effort. We had nothing to implement in that space. If you are starting from scratch, so let's say you have already PDF creation software and you need to add PDFX and PDFVT, I would say PDFX support might even be a larger effort than PDFVT effort. X-object equivalence. There's a whole chapter or a whole annex, the Annex F, about how to determine whether two X-objects are equivalent. And there are some problems or gray areas in that annex. And section F3.1 already has some notes about this. And we came to the conclusion that there are situations where PDFlib would know that two objects are functionally equivalent, but we cannot use this knowledge because otherwise we would violate the standard. And this is a short description of the situation. You can add XMP metadata to almost any kind of object in a PDF file. So you could attach metadata to a FormX object. And of course, the metadata does not have any effect on the meaning of the FormX object. So they are functionally equivalent even if they have different XMP attached. But NXF requires that all dictionaries that are referenced from an X object are evaluated for determining equivalence. So you're evaluating some data that nothing has to do with the functionality of the object. So if we calculate the hashes for the unique identifiers of X objects, we also must go over the XMP metadata, which will result in different unique IDs, although for the RIP, both X objects can be considered identical or equivalent, functionally identical. Okay, I'll skip this step because after further discussion, after I delivered the presentation, we are no longer sure that this complaint is actually true. Object streams, there's a paragraph in the PDFVT standard that says all dpart dictionaries that describe the document part hierarchy tree should be written into a single compressed object stream. And this is actually a contradiction to ISO 32000, which says that you should limit the number of objects in an individual object stream. So we had to decide which recommendation we should follow, and we decided that it's not a good idea to write really, really large compressed object streams. If you have very large PDF documents with hundreds of thousands of pages and maybe hundreds of thousands of document parts, we thought there might be a problem, so we followed the recommendation of ISO 32000.
So it's ISO 32000-2 where the dpart dictionaries is still not finalized. Have you spoken to those people about the contradiction yet?
Well, I think we sent a note about that to Leonard at one point in time.
Leonard, okay.
But and he said, well, we think it's good to have a single compressed object stream for this dpart stuff, if I remember correctly.
I'll talk to Leonard.
But
okay.
it's not. But the recommendation I'm talking about is in ISO 32000.
Yes,
that you should have.
-2.
No.
No.
The recommendation that you should not get arbitrary large object streams
Okay.
is in ISO 32000.
Okay. So we're not talking directly about the dpart stuff that's in 32002.
No.
Got it. Thank you.
We have to make sure it doesn't contradict.
I understand.
That's a good point.
Yes.
Then a few words about the Annex D, which defines a mapping of the document part tree hierarchy of a PDFVT document to an XML representation. And we talked about DPM, which is not restricted. It can have references to arbitrary PDF objects in the document, not just inside the DPM. It's not self-contained, and it could even be recursive. So that's not forbidden by the standard. But that cannot be represented in the XML according to NXD. So this means, as a consequence, that you can construct valid PDFVT documents, but you cannot express them in the XML representation according to NXD. So that's just a fact, and it's probably a little bit academic. Nobody will do that probably. And it's also a question who will use this XML representation.
We'll learn more about that in the afternoon.
Yeah, one difference between PDFVT and ISO 32000-2 is a difference in the definition what can be in document part metadata dictionaries. PDFVT allows streams, or it does not forbid them. PDF 2.0 explicitly forbids stream objects in DPM dictionaries. And as we considered anyway that streams will not be very useful in DPM, we did not implement them at this time for PDFVT. And finally, about the implementation, well, I said that we had to create a new API for the low-level DPM PDF data structures, and fortunately we also can use that for other purposes in PDFlib. We spent a lot of effort that we get the unique identifier calculation right, so that the identifiers do not vary across platforms, time, and PDFlib versions, and hopefully we will be able to keep it that way. As we saw with the programming model in the beginning and in the end, we could extend the programming model in a quite natural way, so it's not really hard for users of PDFlib to create PDFVT documents. We decided to implement MIME support, not directly in the PDFlib core, but it can be easily added on top of it. And it was also a good thing with to interact early with the validator vendors, namely with Olaf's PDF toolbox, because we detected bugs in PDFlib's implementation at that time. But I hope we will also be able to give valuable feedback. There were some bugs at that point in time in the PDFlib validator which are fixed now. So to come to the end, the outlook, we have some licenses of PDFlib VT deployed, and according to what we know, those are mostly used for proof of concept and prototype implementations. We do not know of any real production use. We are waiting for feedback from those users. We are eagerly waiting for feedback from RIP vendors, and it might be a good idea for PDF creation, for RIP vendors and PDF creation vendors to get together and do performance tests. And we will have PDFA2 and PDFA3 support in the upcoming version of PDFlib, which will allow combined creation of PDFVT1 documents with those PDFA standards. And finally, some references. If you are interested in the details, I want to specifically point out the section on our website, which has some knowledge base articles about PDFVT, and we have some real programs programmed with the PDFlib API in the PDFlib cookbook. And what you can also find there are real PDFVT files. So according to our knowledge, these are the only ones available on the internet today. I would be very interested if you can point out other files that claim to be PDFVT compliant. If you are into the technical details of PDFVT, please download the files, look at them, rip them if you can, and give us feedback whether we did the implementation well or not. Yeah, I think that's it. Any further questions?
That's good. Samples are hard to come by.
Then, thank you very much.
Thank you.